Today's AI news sounds like science fiction. Google has unveiled 3 neural tools that can write research papers, generate working code, and build a digital replica of the entire planet. Meanwhile, OpenAI is promising a wave of major launches in the coming weeks, from new models to features that could change the game entirely. Watch this video until the end so you don't miss a thing. OpenAI prepares for a major update, new models, products, and a possible conflict with Microsoft. OpenAI CEO Sam Altman announced on X that the company is planning a wave of new releases in the coming months, from new models and features to entirely new products. He warned that there may be some glitches and capacity overloads during this time, but assured users that they will really enjoy what the team has in store. This post sparked discussion, and judging by leaks and rumors, OpenAI is indeed preparing for a major upgrade to its ecosystem. The most anticipated launch is the new GPT-5 model, not just a single version, but several: GPT-5 Nano, GPT-5 Mini, and the full GPT-5 with varying levels of reasoning depth depending on subscription tier. This format was predicted by The Verge editor-in-chief Tom Warren, who expects the release to happen in early August. His forecast seems credible. Traces of the new model have already been found in the OpenAI API, the ChatGPT Mac app, and even Microsoft Copilot, all signs pointing to an imminent release. But GPT-5 isn't the only thing in the works. There are mentions of a second model with open weights, a long-awaited move from OpenAI that researchers and developers have been asking for. In recent weeks, several mysterious models under the names O3 Alpha, Nectarine, Starfish, Summit, and Zenith have been tested on the WebDev Arena platform. Meanwhile, Horizon Beta, another experimental model previously known as Horizon Alpha, is already available on OpenRouter. Beyond models, OpenAI is reportedly preparing radical updates to its product line. One project involves a proprietary browser with integrated AI, potentially a direct competitor to Google Chrome. Another is Canvas 2.0, a platform for collaborative document editing powered by AI. According to sources, Canvas 2.0 has been ready for some time, but its launch is being delayed, possibly due to concerns about friction with Microsoft, OpenAI's largest investor. Canvas may overlap with Microsoft's own Office suite, creating a conflict of interest. In short, the coming weeks may be a turning point for OpenAI. The company seems ready to unleash not just an update, but a wave of new technologies that could reshape the market. The key question is how partners will respond, and whether the infrastructure is ready for such a large-scale rollout. Singaporean startup Manus is once again in the spotlight with the launch of its experimental feature called Wide Research. While major players like OpenAI, Google, and Shy are focusing on deep AI research with a single powerful agent that sequentially analyzes information and produces a detailed report, Manus is offering a completely different approach, distributing the task across 100 agents working in parallel. In a demonstration video, the company's co-founder Yichao Peak Ji shows how 100 agents simultaneously analyze the parameters of 100 sneaker models. Each agent is assigned one pair and evaluates its design, price, and availability. Within a few minutes, the user receives a structured report, a table, and a web page with the results. And all of it happens automatically, with no manual setup. But Wide Research isn't limited to data analysis. In another example, agents generate posters in 50 different design styles, all in a single task, simultaneously. The finished assets can be downloaded immediately. This is made possible thanks to virtualization and a new architecture that scales computing power by 100x. The system doesn't use narrow roles like manager or coder. Each agent in Wide Research is a fully independent Manus instance, capable of handling any general task. The feature is already available to users on the Manus Pro plan and will later roll out to Plus and Basic tiers. The most accessible version is free, with a limit of 1 task per day. The Pro version costs $199 per month and includes access to 10 concurrent tasks and early features. However, not everything is so clear-cut. Unlike deep analysis tools, Manus has not yet provided performance comparisons to prove whether the wide approach is actually more effective. It's also unclear how agents communicate or how their results are merged. For now, this is more of an architectural experiment than a proven breakthrough. Still, the launch of Wide Research shows where the industry might be heading. Instead of building one increasingly complex universal agent, Manus is betting on many simple but fast ones, each taking a small part of the job. Whether this turns into a stable technology or runs into technical challenges remains to be seen. NVIDIA makes 3D video accessible to everyone, a new breakthrough in immersive technology. At the GTC 2025 conference, NVIDIA researchers unveiled a technology that could redefine how we experience video and virtual reality. The OMRI team presented a system that allows users to watch videos in real time from any angle, as if they were actually inside the scene. At the heart of this technology is a development called Queen, a new method for compressing and playing back 3D video in a lightweight, fast, and highly realistic way. What does this mean for viewers? Imagine watching not just a recording of a boxing match, but being able to move around the boxer and see every punch from any perspective. Or witnessing a family moment as if you were standing right next to the characters. This is made possible on special 3D displays like Looking Glass, as well as VR headsets, with high resolution, smooth animation, and full freedom to move the camera. At SIGGRAPH 2025, visitors could experience this immersion firsthand, controlling the point of view with a mouse or head movements. The secret of Queen lies in its unconventional way of storing information. Instead of traditional 3D models, the system uses so-called Gaussian splats, compact data points that update from frame to frame. These points can be compressed to less than a megabyte per frame while maintaining high image quality and enabling the system to train in just a few seconds. Meanwhile, it can render at over 300 frames per second, far beyond standard video rates. The technology also distinguishes between static and dynamic objects in a scene, speeding up processing. For example, in a boxing scene, only the boxer's movements change, while the audience remains static, reducing system load. This is especially important for streaming, where minimizing data transmission without losing realism is critical. The Queen project is a step toward making immersive video mainstream and accessible. Previously, such experiences were reserved for large studios or exhibitions. Now they are coming closer to everyday users. NVIDIA demonstrates how video can be more than just something you watch. It can be something you enter. And while streaming used to mean simply choosing video quality, it now means choosing your angle, your depth of perception, and your level of immersion. Google is once again redefining what artificial intelligence can do. In just a few days, the company unveiled 3 innovations, each targeting completely different domains, from scientific research to planetary mapping. What unites them is this: they can perform complex tasks that previously only humans could handle, and possibly do it even better. The first of Google's 3 new breakthroughs is a system with a bulky but important name, TTDDDDR, or Test Time Diffusion Deep Researcher. Despite the complex acronym, its essence is both simple and ambitious, to teach artificial intelligence to think like a real human researcher. Unlike many modern AI systems that merely digest internal databases and spit out ready-made text, TTDDDDR builds its answers step by step. It doesn't just generate results, it reasons, plans, searches for information, drafts, rewrites, analyses its mistakes, and starts the process again, constantly improving the outcome. This is its core distinction: the ability to think and process, not just output. The way TTDDDDR works resembles cleaning a blurry photo. At first, it sees a vague outline of an answer, then gradually refines the details until the final result is clear, logical, and in-depth. And it doesn't do this in isolation. At every step, the system pulls in up-to-date external information from the internet, academic databases, or recent publications, and integrates it directly into the draft. This allows it to stay in context and maintain coherence, something most AI systems struggle with when relying solely on internal knowledge. Google conducted extensive testing of TTDDDDR on some of the most challenging research problems, the kind that require more than just definitions. These tasks demand hypothesis building, evidence gathering, critical evaluation, and well-reasoned conclusions. In such complex scenarios, TTDDDR consistently outperformed competitors, including OpenAI's Advanced Research Agent. The system showed a particularly strong edge in long-form reports and multi-step reasoning tasks. In direct comparisons, nearly 3/4 of users rated TTDDDR's outputs as more helpful, complete, and logically sound. Under the hood, the system runs on an entire architecture of smaller AI agents, each responsible for a specific phase. One plans, another searches, another analyses drafts. These agents work together in a unified pipeline and can adapt in real time. If a stage fails or underperforms, the system analyzes the issue and reconfigures its approach to improve. Google calls this mechanism self-evolution, real-time self-improvement. It mirrors how a human learns from mistakes and changes strategies to get better. This makes TTDDDDR more than just a helpful assistant. It's a potential replacement for entire research departments. While most AI frameworks are bound by rigid templates and scripts, TTDDDR demonstrates flexibility, focus, and the capacity for genuine intellectual work. And if this technology continues to evolve, it could fundamentally reshape the nature of scientific and analytical labor. Google's second breakthrough isn't just a smart program, it's a true engineer, only digital. The system is called MLE Star, and it functions as a full-fledged AI developer capable not only of writing code but also of understanding the entire machine learning model development process from start to finish. And it does so with a level of precision, thoroughness, and adaptability that was previously reserved for experienced professionals. MLE Star starts by analyzing the task at hand, for example, image classification, tabular data processing, or regression. Then, instead of selecting a cookie-cutter model like many other AI tools, it searches for the most advanced architectures from recent scientific publications and repositories. If the task involves image recognition, it won't default to outdated networks like ResNet. It will reach for efficient net or vision transformer if they offer better performance. All of this happens without any human prompting. But when human input is given, say, a suggestion to use a multi-layer perceptron, MLE Star instantly adapts and integrates it into the pipeline. Once the base code is generated, the most fascinating part begins: optimization. The system methodically tests every stage of the pipeline, from data ingestion to ensemble techniques. It identifies which components actually impact performance and which ones are dead weight. For instance, if feature engineering turns out to be the key factor, MLE Star focuses on it, proposing and comparing alternative strategies. It isolates the weakest link and polishes it to perfection, working in a loop: try, analyze, revise, try again. One of the standout features of MLE Star is its approach to ensembles, where multiple models are combined to improve accuracy. While standard tools simply rely on voting mechanisms, two say yes, one says no, result is yes, MLE Star builds its own merging logic. It experiments with weights, merging strategies, and even creates entirely new approaches based on previous iterations. Google also placed special emphasis on reliability. The system has 3 built-in safeguards: a debugging agent to catch execution errors, a data leakage checker to ensure test data isn't accidentally used during training, and a data usage validator to confirm that all provided data sources are actually used. This is crucial. Many models skip over complex data types like satellite imagery or JSON files in favor of simple CSVs. MLE Star misses nothing. The system was tested on Kaggle through the MLE Bench Lite benchmark and showed its real strength. It earned medals in 2/3 of the competitions it entered, with 1/3 of those being gold. For comparison, previous best-in-class AI systems only won medals in about 1/4 of the cases. That's a major leap forward. In analyzing the system's behavior, researchers noticed something remarkable. MLE Star actually thinks. It avoids classic mistakes, like using test set statistics during training, a serious violation in machine learning. It checks task descriptions, ensures all data is accounted for, fixes bugs in generated code, and adapts seamlessly to changing requirements. And perhaps the best part, MLE Star is open source. Google released it as part of the Agent Development Kit, meaning anyone can start using it today in their own projects. This levels the playing field, putting a high-level ML engineer in the hands of not just large companies, but individual researchers and developers too. And it seems this is only the beginning. Google's third innovation stands out not only for its technological sophistication, but also for its sheer scale, quite literally planetary. Alpha Earth Foundations, AEF, is a new kind of artificial intelligence that acts like a virtual satellite, capable of generating detailed maps of the Earth on demand, without waiting for a satellite pass or manually stitching together fragmented data. It's more than just a tool for geographers, it's an ambitious attempt to create a digital twin of the planet, constantly updating and analyzing itself in real time. AEF collects data from a wide range of sources: satellite imagery, climate models, drone footage, field sensors, radar scans, all of which were previously stored separately in different formats, at varying levels of resolution and quality. AEF unifies this information into a single system that researchers call embedding fields. Each of these vectors represents a 10 by 10 meter patch of land, and there are millions of them. These vectors don't just describe topography or vegetation, but also include climate variables, infrastructure, water bodies, roads, buildings, anything that can be captured and digitally represented. The database covers the entire surface of the Earth going back to 2017, including every location, regardless of how recent or complete the imagery is. One of AIF's most powerful capabilities is filling in the gaps. If a region lacks fresh imagery or has been obscured by cloud cover, AIF doesn't simply return an error like most systems. Instead, it reconstructs the missing information using multimodal reasoning, drawing associations with similar regions and pulling from other available sources, radar, textual data, historical images, even satellite surface temperature, to rebuild the map as a human expert might, relying on context. At the heart of AIF is an architecture known as spacetime precision, which allows the system to process data along three axes simultaneously: space, time, and resolution. It uses attention layers to recognize spatial patterns, temporal layers to track change over time, like desert expansion or glacier melt, and multi-resolution blocks to preserve both fine details and the broader picture. What's even more impressive is that AIF can understand text. It reads and interprets geotagged articles, reports, and Wikipedia entries, using this semantic information to enhance its maps with context. So even in places where satellite data is available but lacks structure, AIF can understand what's there or what's happening based on human-written descriptions. And this isn't just a theoretical system, it's already in use. Organizations such as the United Nations, the government of Brazil, environmental science teams, and research universities around the world are using AIF to monitor deforestation in the Amazon, track urban sprawl, detect the disappearance of wetlands, follow shifting sand dunes, and analyze other slow but significant environmental changes that previously required months of manual analysis and fieldwork. Most remarkably, AIF can generate a map for any region of the world and any date since 2017 within seconds. No delays, no waiting for weather conditions, no manual merging of datasets. Everything is done automatically, reliably, and with high precision. Access to this data is provided through Google Earth Engine, meaning even small teams, students, local researchers, activists, now have access to tools once reserved for top-tier geo-institutions with supercomputers. According to Google and DeepMind, this is just the beginning. Their future roadmap includes even higher resolution, integration of localized knowledge, additional data modalities, and the creation of dynamic digital Earth twins, living models of the planet that reflect changes in real time. From floods and wildfires to wildlife migration and urban expansion, these models aim to offer a continuously updating window into the state of the Earth. And this is no longer science fiction, it's the future unfolding right now.